Hi guys, today's lesson is going to be on factoring trinomials where a is greater than 1. So what do we mean by a being greater than 1? Recall that we have been factoring quadratic expressions where by quadratic we mean that the highest degree is a term squared. So remember that this term is known as our quadratic term. Sorry about that. This term would be known as our linear term. And this term would be known as our constant term. So when I refer to these terms, I need you to know what I'm talking about. So when our a value is greater than 1, we are referring to the coefficient of our quadratic term. So let's consider this first problem. If you are asked to factor this expression, we first need to remember what factors are. Recall that factors are numbers that when multiplied give us a product. So if we look at 3 being multiplied by 2, which equals 6, we know that 3 is a factor of 6 and 2 is a factor of 6. So that's all we're doing is thinking, what two things can I multiply together? In this case, two things. Can I multiply together to get 3x squared minus 2x minus 5? So what we're going to use is the x method, which we've also said was the diamond method, because if we connect these, it kind of looks like a diamond. Actually kind of looks like a box turned on its side, right? So sometimes you can hear it referred to as the box method, a reverse box rather. And what we first want to do is multiply our a times our c value. So first, multiply a and c. The values we get here will be substituted at the top of our box, or x. So remember that our a is our coefficient of our quadratic term, our c is our constant term. So that's our 3 and our negative 5. So 3 times negative 5 gives us negative 15. So I'm going to place that in my the top of my x. Next, I always put my b value in the bottom. So think b bottom. So my b value, which is negative 2, the coefficient of my linear term, will go down here in the bottom. My next step is to find factors of AC that combine to give me b. Okay, factors of c that combine to give me b. So if you think about what numbers you multiply to get 15, don't worry about your sign right now. You should be thinking, well, I know that 15 times 1 gives me 15, and that 3 times 5 give me 15. So 15 and 1, there's no way to make 2 out of 15 and 1, so I'm going to use my 3 and my 5. But you always need to check. Now 3 and 5 when multiplied give us a positive 15. If we have a negative 15 as our constant, or as our product of a and c, then we need one of our factors to be negative. What determines that is whether we need a positive or a negative 2 here. So since it's a negative 2, the larger of my factors will be negative. Why? Because 3 plus a negative 5 is a negative 2. So now that we've established that, we're going to do next what we call the bottoms up method. Meaning, my next step is to take these factors that I found and divide by a. Now, of course, by a, I'm referring to the coefficient of our quadratic term again. So since my a value is 3, I'm going to take both of these terms and divide them by this 3. So I'm getting there. The next thing I need to do is simplify either of these if they can be simplified. Negative 5/3 we would leave as an improper fraction. We cannot find any other common factors other than 1. However, 3 divided by 3 is equal to positive 1. So I'm going to take this 1 and this negative 5/3 and create my factors. So fourth, I should put up here, take the factors and divide by a and reduce. So fourth, I want to set up factors. So to do so, I'm going to take this 1 and write, using my same variable, x plus 1. Y plus 1 because 1 is positive. Next, I'll do likewise for this other factor, but since it's a negative, it will be x minus 5/3. Because I have a fraction, I'm going to take the bottom and move it up, hence the bottom's up. So once you recognize this pattern, sorry about that. Once you recognize this pattern, you'll take this bottom and simply move it up, and you can do it straight from here when you find it. So that leaves my first factor, x plus 1, and my next factor, 3x minus 5. So I'm just rewriting it, but relocating 3 in front of the x. So I am through factoring. What I want to make sure that I do is check it to make sure it works. So remember your double distributive property. X times 3x gives us our 3x squared that we started with. That's good. We can check our c term, our constant. 1 times negative 5 is negative 5. But now we're going to do that chin and grin check, which is where, this kind of looks like your chin. Multiply these two terms together, that gives you 3x. Multiply these two terms, looks like a big old grin. Then you get negative 5x. When you combine those, you get negative 2x, so it checks out because that's our linear term. So these are indeed our factors. Of course, it is perfectly fine to list them as 3x minus 5 times x plus 1 also. Either of those is acceptable. So to finish up our steps here, we're going to set up our factors, and then if a factor has a fraction, relocate the denominator of that fraction in front of we'll say the x here, meaning right here in front of your variable in that factor. Okay? And of course, like always, we want to check our work. To do that, remember that we can use our calculator. We can also multiply it out. But one thing I've taught you in class is that you can store a value and test to see if these are equivalent values. So next what I'm going to do is remind you of how to do that. So remember, you've learned to store values, and I really don't care what value is stored. To be honest, all we're trying to do is check to see if our original expression is equivalent with our factored expression. So I'll just say we'll store our 3 as an x. Store 3, why not? So what this means is that every time the calculator sees x on this home screen, that it will substitute the value of 3 and simplify the expression. So if I type in 3x squared minus 2x minus 5, our original expression, and hit enter, I get a value of 16. The value of 16 is not important. What's important is that when I type in my answer, I get the same thing. So I'm going to type it in, hit enter, and notice that these are equivalent. That tells you that your answer is equivalent also. We also want to make sure that we always are pulling out any common factor in case you miss it here for this factor, okay? So make sure it's completely factored, and this here is your answer, x plus 1 times 3x minus 5. I'll do one more example to make sure that you're understanding. Let's see, well, actually 2 more examples. I want to do another one where we pull out a GCF. So next, let's consider 5n squared plus 19n plus 12. Remember, when you look at a polynomial expression, you always want to try to factor out any GCF first. In this case, because 5 is prime, 19 is prime, I know that I'm not going to have any other factors that I could pull out other than 1. So I'll begin with my x. I multiply my a and my c value. 5 times 12 is 60. My b value goes at the bottom. And then I want to find my factors of 60 that combine to give me 19. So if you aren't sure, you kind of play with those numbers. In this case, 60 has several different factors. You could try 6 and 10, 2 and 30, 5 and 12, and maybe eventually you'll get to the correct one, which would be 15 and 4. So since 15 plus 4, they're both positives, which means we're going to add the factors here. No negatives here. 15 and 4 are the winners. 15 and 4 multiply to give me 60, but add to give me 19. Since I have these values, I'm now going to take my 5, my a value, and simply divide by 5. I'm going to reduce either of these that can be. 4/5 cannot be reduced, but 15/5 can be reduced to 3. So I'm going to take these values and create my factors, being sure to use the same variable that's in my original expression. So I'm going to have n, and because 3 is positive, n plus 3, and n plus 4/5. Now I implement my bottoms up and take the denominator and move it in front. So I'll have n plus 3 times 5n plus 4. So quick chin and grin check. After verifying that my first and last terms are correct, n times 5n does give me 5n squared. 3 times 4 does give me 12. 15n plus 4n does give me 19n, so I'm good to go. And here is my answer. I'm good. The next one I want to show you is one where you would factor out a GCF first. So let's consider this problem here. If I take a look at this one, I notice that 9, 66, and 21 all seem to have a common factor. In fact, they are all multiples of the number 3. So if I put a 3 outside, then on the inside, I'll put the quotient after dividing out the 3. So 9r squared divided by 3 is 3r squared. 66 divided by 3 is 22r. And 21 divided by 3 is 7. So what this tells me is that when I finish, I'll not only have the 3, but I should end up with 2 binomial factors. So let's see if we can do that. So now I'm going to create my x, making sure that my product here of 3 and 7 goes up top. So no longer are we doing 9 times 21 because there was a common factor. So 3 times 7 gives us 21. My 22, my b value here, will go here at the bottom. 21, this pops out that 21 and 1 add up to 22. So I feel comfortable with that. 21 times 1 is 21. 21 plus 1 is 22. I take these values, divide by the new a value since I factored out this 3. So my new a for this trinomial I'm factoring is 3. So I'll divide each by 3. Reduce. 1/3 cannot be. So what I'm going to do next is show you that you can go straight from this to your factor. And generally when you see factors listed, if there's going to be a number in front of the variable, it's usually listed in the first factor. So I'm actually going to move this one over here, although it technically would give you the same thing. So I'm put the 3 in front of r and simply write it as 3r plus 1 because my 1/3 is positive. And then I'm going to take my 7 and write it as r plus 7 because 7 is positive. So I feel pretty comfortable with it, but probably the quicker way would be to check my answer on the calculator. So I don't need to restore a value. I can, remember, you always use x on your home screen. 9x squared plus 66x plus 21, and then type in my answer. Noticing that since they are giving me the same output value, that my answer is correct. And that concludes my video. Thanks.